Does everybody have their z-score chart still? Yes. Does anybody not know what a z-score chart is? Meaning you need one. Everybody's got their z-score charts? Oh, what's up? You need one? Have some somewhere there. Everybody else is good? All right, guys, can you please, if I'm given a normal distribution, the mean is 207, and the standard deviation is 11.19. That's pretty good. Sorry. And I want to know what's the probability that I pick something that is more than 212. Can you guys tear into that problem? You should all have calculators still, right? So, can you draw the problem? Can you just draw it? I told you it's normal, so what's it look like? What's up? What's it look like, guys? What's it look like? Bell curve. I love it. What goes in the middle? 207. 207. What else do I put up on there? Yeah, put 212. Right. And where's 212? No, I don't have to do two standard deviations.
That way.
Yeah. 212.
And you're shading to the right.
And I want to know greater than, yes?
Yes.
Okay. That is you being nice to yourself. I already know that the answer is going to be less than what? Less than 50%, right? So if I don't get something that's less than 50%, from a picture I know I'm wrong. Yes? What's the next step? Do it. Did everybody hear that? Next step is z-score, because I can't use the chart of answers, right? Sounds like a D&D thing, the chart of answers. I can't use that unless I have a z-score. So don't say anything. Can you convert that to a z-score? What's the z-score formula?
The number you're looking for minus the mean over the standard deviation.
Okay, so help me out. Don't say anything yet. Let everybody try to do it. Try to convert that. Normally, if you get anything outside of -5 and 5, you're almost definitely made a mistake. I'm not saying
the chart, you're like, where's 212 on this chart?
yeah. I'm not saying it's impossible to get a z-score of like 18. Right now, are you guys understanding that if I told you that somebody's z-score was 7, somebody's z-score for their height is 7, what's your reaction to that?
They're the world's smallest or tallest man.
No, 7, not -7 person. 7. They are insanely tall. Z-score of 7 is stupid. Between what two, how many, what z-scores? Between what two z-scores is 95%? From -2 to 2, right? So if I have a z-score of 7, that's insanity. That is, do you guys understand? And throughout the semester, we're going to get a better feel for this. But when I get z-scores above 2, that is an unusual territory. Z-score of 7, I'm like, if I didn't make a mistake, this is some weird shit. That is way outside of the bounds of what I should expect, right?
Should we round up?
How much should you round the z-score?
4.
4.
Why 2 places for the z-score?
Because there's only 2.
Yeah, the chart's got 2 places, yeah.
Well, I know, but if we get like say 0.446, are we gonna round up?
You round it.
0.45?
You round it. You don't chop it, you round it. So in that case, 0.45.
0.45.
Yeah, all day long. Even on Tuesdays. So this will be my data point minus the mean divided by the spread. The given mean is always here. The point that I'm interested in, that the question asks me about, is always first, right? Because you know from the picture it's going to be a positive z-score, correct? So if you do this work and you get it negative, stop. You know you're wrong. The picture again is helping you. I know it's going to be a positive z-score. It's above the mean. What'd you guys get? Is that what you got?
0.45.
0.45?
Yeah.
446? Whatever? I'm crowdsourcing right now. Can't do that in my head that precisely, so. Okay. What's the next step?
Find out.
Find the area from that Z-score.
Do you understand that somebody, I'll get people to do this, you ready? I'll get people to do exactly this. And then they'll say 45% and they'll circle it.
Because it looks like a percent.
Yes. Z-scores look like percentages if they're below 1, right? You know better. So you gotta tell yourself what you're doing. I'm calculating a Z-score. That is a Z-score. It's not a percentage yet. It's not a probability yet. You guys with me? Keep track of what the hell it is you just did. All we did is calculate a Z-score. Have you guys looked it up yet?
Yes. Area 0.6736.
And where's that? Is that the answer?
No.
Where's that?
Everything to the left.
Yeah. It always tells me the area below.
So we gotta
Say it again. That
subtract.
wasn't real instant.
0.6736.
6736. 36.
You gotta subtract that from 1.
Does everybody agree with that? And so, my real question is, if you don't get that number, tell me, so I can help you find where that is, right?
I did your trick.
When you did the negative? Yes. Little cheer.
So proud.
So to get this answer from what we know, like Martin said, you gotta subtract this from 1, and the shortcut is 3, 2, 6, 4.
My brain won't let me do that.
999.
I learned one way, it won't allow that.
Make it 9, make it 9, make it 9, make it 10.
So I got,
Or, you know.
that's 32.64%.
We got calculators, why not use them? I don't blame you. Okay. Huh?
32.64%.
Yeah, 32.64% chance.
Or flip the page over.
Okay. Huh?
Flip the page over.
Flip the page over?
Well, yeah, because if your 0.45 is
Oh, yeah.
everything to the left,
Yeah.
then your negative 0.45 is what the tree.
Beautiful, yeah. So the shortcut, somebody did this, if you look up negative 0.45, you'll actually get the exact answer. And the reason is, it's symmetric. So the area above 0.45 is exactly the same as the area below negative 0.45 because it's symmetric. That's all there is to that little shortcut. It's barely a shortcut. You save like half a second, right? But you know, that adds up. You guys all with me? You never have to use a shortcut if you don't want to. Okay, all right. Let me help us out today, okay? I'm gonna let us out early today. You all look, and I'm really sorry, we all need this break.
He's like,
You all look the way that the big part of me feels right now. You're all out there like,
I feel bad for you, you're gonna be grading all.
I understand,
Barely open, brain is fried.
I understand.
He's gonna be like, the grade.
What I normally do in spring break is my whole first weekend, like this weekend coming, I'm gonna be grading everything. And then I'm gonna go. I'm gonna go hiking, I'm gonna go freaking do whatever the shit I
I'm
want.
going tomorrow.
Oh, yeah.
I don't know where I'm
I know,
going, I'm just.
but I don't like stuff. What's that?
Just moving.
What's that?
I said, I don't know where I'm going, I just know I'm going.
Oh, you.
Can I still turn in?
That's the best kind of trip to take.
Chapter
Huh?
3 next, the week after next. Chapter
Sure,
3.
yeah. So chapter 3 homework is officially not due yet.
Oh.
Because I said I would make it due the day of the test to keep it the same as all the other
I'm
homework.
just paranoid, I got 40.
Alright. Don't get excited. When I said early, I didn't mean this freaking early, so we're not leaving right now. Alright, I love you guys so much. Okay. So, if there's no questions on these kind of problems, this is section 6162. This specifically would be from 6.2, if I remember correctly. I think 6.2 is where they introduce, you have to use the Z-score formula, right? Let's do one more real quick. Same problem, same stuff, but now I want to know what score is represented by P73.
Oh, that's your ear.
Ooh. What's the big ass P mean again? Percentile. What do percentiles mean? Where's that?
That
73.
underneath.
Yeah. Do you see how that syncs up perfectly with the Z-score chart, right? So now I go into the problem knowing the probability, knowing the area. First step is to figure out the Z-score. Don't say anything, try to find it.
Give us a little note, like on Monday saying when you're going from one to another, use the chart and then for.
Oh, yeah,
one,
so
like,
here's the complete thing there, this, when you're going, if they give you a raw score, you can figure out your z-score and go to, so this is the formula. And this is the chart, right? So this would be z equals x minus the mean divided by standard deviation, right? If I go the other way, if they give me a percentage, I can look up the z-score in the chart, and then I can go back using the same formula just written in reverse. Yeah.
Whoa.
Tripedelic. You're the first class that's actually reacted to that.
They
positive. I thought this was pretty good, but everybody before this had been like,
No, because that makes it so much easier.
so you got to really identify what they tell me. Is it a raw score or is it a percentage? So I know which way I'm going, right? So don't say it. Has anybody found the z-score yet? Don't say it. Do you guys remember how to find it? Are you gonna find 73, 0.73 exactly?
No, we're gonna get as close as you can.
Close as you can. Almost definitely you won't. Sometimes you will, but most of the time you won't. So let me put it up here real quick. Come on. There we go. Oh shit. Now that song stuck in my head. Okay. Kind of went like.
No. You've been watching Guardians of the Galaxy too much? Get that song stuff in here.
That's just. So am I gonna look at it as a negative one or the positive?
Positive.
Yeah, it's gonna definitely be up to have that much area beneath it. Then I'm trying to find my sevens, right? Where's my sevens at? So 0.7.
17.91.
And I'm trying to find 7.3.
17
Yeah.
closer.
This is 24 away. Does everybody see what I mean by this is 24 away? This is only
8
9 away. So therefore, what's the z-score?
6.61.
0.61. I like it. And everybody at home, you just missed all of that. If you're sick, you're okay. Otherwise, you'd be here. So 0.61 is my z-score. How do I get that into a raw score?
Multiply it by standard deviation.
So I just go plug it in that formula, right? The backwards formula. To get the raw score, I take the mean, start at the mean, and I go this many of these. And that's what the z-score means, right? The number of standard deviations from the mean. Start at the mean and go this many of these.
213.8.
Sounds about right. 213.8, is that what you guys are getting? Okay.
213.
In the formula, what is that? X equals M plus what?
Mu, x equals mu plus z sigma. Do you guys remember this is the one that's the definition of a z-score? Remember that's the question I'm gonna ask you on every test?
Oh, yeah.
And you'll have the answer on your formula sheet. And still over 50% of you will get it wrong, but oh well, what can I do? What's the z-score? It's the number of standard deviations from the mean to the data point. Right? If I start at the mean and I go this many of these, I end up at the data point. So a lot of formulas, you can read it like a sentence. Just the hardest part about math is translating from Mathish to English, right? I always think in my head, speak friend and enter. It's like, how do you say that in math? Yeah. Oh, alright. Are you cool with 73% as a percentage, right? Okay. The closest I can get, and again, what lives on the outside of the chart?
Z-scores.
Z-scores. What lives on the inside?
Area.
Percentages, areas, probabilities. The closest we can get to 0.73 was right up here. What z-score is that? 0.6.
Okay.
Yeah, so normally I look from the z-score in. This I can look at it and then look out to see what the z-score is. Right? Yes.
Is there like a trick for, like, let's say you have a z-score, like an area that's really close, but there's one that's way over there that was closer, but I just missed it.
Oh, that happens sometimes because, of course, this is like a Pac-Man game because it kind of goes off and comes back on, right? So Where's a good example of that? Like, blah, 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 blah. I don't know if I can find one real quick. I don't know. No, screw it. Do, 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 do. This is fun, Jeff. We appreciate this. What about, meh. I don't know. But yeah, so for example, you're over here, you get like, but the answer could be over here,
Yeah,
right? Okay, that could happen, I just can't find one real quick.
that's what we can do.
You just pick the one that's closest, always. Just make sure that if you're in the first column, make sure you look over there too, just to make sure it's not valid. Oh my god, I gotta look way on the other side of the piece of paper.
If we just accidentally pick the wrong z-score, are you, the whole question, you're gonna say it's wrong?
Yes.
Or are you just gonna be like, oh, you were close, that's like -2 points, like.
If I was a Scantron person, meaning I'm not a math teacher, if I was a Scantron person, then yeah, then it would be totally wrong. But I'm a partial credit person, so you would just lose points on that one piece. If the rest of it was right, you're gonna get most of the points.
The
I
formula.
love you guys. You don't know that yet? Am I not graded enough for your shit yet? So, if the z-score is supposed to be -0.5 and you put -0.51, I could take a point off or something, you know? You're gonna get most of the points if you do the rest of the problem correct. You just have the wrong z-score number? Yeah. Okay.
You said the formula's gonna be on the sheet, but I still get confused by it because I don't use it. I just plug in the z-score we get.
Oh,
in the regular.
yeah, you don't have to use this formula if you don't want to. You
But
can-
it helps answer the question, and I forget which question it is, because it's a definition, it's x equals the distance from the mean by the number.
Yeah. What's this mean? The number of standard deviations from the mean to the data point.
And what does that define?
What's that define?
The number of students.
No. What is that the definition for? Z-score, yeah, that's what a z-score tells you, yeah. Okay. Alright. Enough of that. So you guys gotta get in chapter 6 and try it out. We're gonna get to chapter 7. Today I'm gonna throw a lot of concept at you, and then after the break, we'll do some concrete stuff. Today's gonna get trippy. We are gonna take a trip, which is why I like the Rick and Morty. We're gonna take a trip to an alternate universe today.
10-minute adventure, please. Good.
Some of you guys are like, what the shit is this guy
Wait, do I
talking
have to leave this classroom?
about? No, you don't.
Okay.
Or math is the definition of anything, it was all the
Yeah.
definition of religion.
Change the equation, reality changes. When I was little, I used to think that would happen. Like if I wrote the equation for the universe, I thought if I erased part of it, I could change the universe. And they're like, "No, you were weird your whole life."
I'm just really into sci-fi.
Yeah. Okay. I'm kind of excited. So, chapter 7 is trying to get us closer to reality. So we've got the basics of the z-score chart. I think I mentioned the fact that the problems we can do are very contrived. They're not quite real life fully yet. Because what do we normally do in statistics? What's normally our very first step in almost any statistical analysis we're going to do? We take I take a sample, correct? Now, that's not everything, but most everything we're gonna do statistically, I wanna first take a sample, correct? You guys kinda with me? Do you disagree? You're all like, just get your shit out so you can let me out, Jeff. All right, geez. So, what we've been doing in chapter 6 was picking one person, one thing. That's not really true to life. We normally take a sample. And then I'm curious about, is that sample unusual or not? Not just, is this one person an unusual amount or not? Okay. So, in an alternate universe, Florida has a very strange distribution of ages. It's actually not far off from what it actually is. So in this alternate universe, Florida, otherwise known as ALF,
They all retire there, right? That's
well, yeah, it's like a weird Logan's Run in the middle. I don't know if anybody knows that. So their ages go from 0 to whatever, we'll just say 120, sure. Right, the oldest person is about 127. So it goes like this.
You guys with me? And there's no middle-aged people.
So, how did I create this picture? I went around Florida and I said, how old are you? I'm 2. Okay. 2. How old are you? I'm 87. Okay, 87. How old are you? I'm 17. All right, 17. Yeah. So, and then I just plotted stuff up. You guys with me? What's unusual about this?
It's not a normal distribution.
Well, okay, it's not normal, which is fine. It's not. That's not unusual at all. Most shit's not going to be normal.
A mass casualty event.
How many? Let's say this is 40. This is let's say this is 35, and this is 50.
No, people in the prime of life leave Florida. That's what we're seeing.
Yeah. You guys got it with me? And again, I don't know if you've ever been to Florida, but there are quite a few young people, and there's quite a few old people. So I mean, a lot of people retire in Florida, so forth. You guys all with me? Okay. So this is alternate universe Florida, where specifically there is nobody between 35 and 50. Is everybody with me? Okay. Everybody agree this is a rather strange distribution. Okay. But this is a distribution that actually happens. It can totally happen. All right. So this is n equals 1. I went up to each person and I got their age and I kind of put dots and then I built this up. Are you guys with me? So one of the most common ages is roughly 18 or so. Yeah? And another most common age is whatever the shit that is. All right. 85, something like that. Are you guys all with me so far? Where's the mean, roughly? Maybe there. Yeah, let's just say it's there. You guys with me? Okay. All right, so everybody understand the setup? I know it's weird, and I'm really sorry, but I've been doing this example forever, and I can't get out of it. I think it's still good. So, what if instead of picking one person, real quick before I forget, there's a mean, and there's a standard deviation, whatever the hell it is, there's a standard deviation. Right, there is one. Okay, I could calculate it, put it all in the list 1, and here. Okay. What if instead I had picked 10 people at a time? I go up and I get a group of 10 people and I say, what's your average age? I help them get their average age, and then I plot that. Is everybody with the idea? Is everybody with the idea? Let me put it over here. Oh, screw it. I'm going to put it there because I want you. Yeah. Is it likely that I would randomly pick a bunch of people from right there?
Possibly.
Of course it's possible. Is it likely that would happen? No. Could it happen? Yes. Is it likely? Shit, no. If I just randomly pick people, it is very unlikely that I would get just people from right there. Can anyone tell me what the most likely thing is to happen if I just pick a random group of 10 people? I like the guess.
You'll get some from each group.
Yeah. So I would expect a mixture from each, correct? What does the mean I would expect to get for any given sample? What's another name for expected value? Average, right? So for any given sample, I would expect to get this. Are you guys with me? Yes. So if there's an average age at Grossmont, and I go pick a sample of whatever, I'm going to expect to get that average age. Am I going to get that average age? It's going to be off one way or the other. You with me? We know it's going to be off, but what do we expect? I expect to get something around the actual average for any sample I take. Why? Because statistically, I should get some above and some below. It should kind of average out. So pretty semi with me so far. Everybody agrees it would be very strange to get just a bunch of like little, how old are you? Can't talk yet. Oh man, telepathic. No. Right? It really would be unusual to get just a bunch of people that are like a month old. That would be very unusual to happen. I should get a mixture. Therefore, if I were to plot every group of size 10 I could possibly take, and I get their average and I plot it, I'm just going to draw this. This would become like this. The highest point would be here. And then there would be a little bump here and a little bump here. No, it's too big. It doesn't matter, Jeff. It's just a freaking alternate universe thing. Are you kidding me? Okay. Most of my samples that I take should average to be close to the actual average. Does that make sense? Some of my samples I take The next most likely thing to happen besides a mixture from both is a sample where I get a bunch of stuff, you know, from one of these two. That's why there's a little peak here and a little peak there, yes? Are you guys semi? And now real quick, right now you're worried about what the hell this means for you for homework, and I do not blame you. This is the idea behind a remarkably simple adjustment to work we've already done. The concept is insane. The work you're gonna do, easy. Keep hold of that, okay? Keep hold of that. You're with me? All right. Does everybody sort of get this idea? I should get a mixture most often, which means when I help me out. What does that dot mean right there?
The average of what you.
The average of some group of 10 people, correct?
Is
What does that dot mean right there?
one person?
One person's age. Kick ass. Is this normal?
No.
No.
Does it look more normal than this?
Yes.
Shit, yeah. Okay.
Is it more normal
Sorry.
because it's an average?
I'm overreacting. Huh?
Is it more normal because it's an average from 10 people as opposed to one person?
Yes, it is. So watch this. The really trippy thing is, once I hit something above 30, once I get a sample size above 30, no matter what the hell it looked like at first, it's now gonna look like this. Right? Give me some board license. It's now gonna be normally distributed. Once I get above 30, how did we figure this out? To be really honest, we just shoved a bunch of data into a computer and said, do it. And we're like, oh yeah, every time we get above 30, it's like normal. And to be really, really honest, it's a little more than that, but that's basically what we did, right? Are you guys semi with me? The bigger the sample I take, the less likely it should be that I'm just down here. The more I should be getting a sampling from everywhere. The harder it is to get away from having some from both groups. I'm almost never gonna get 40 people from right there. Holy shit, but will it happen? Yes. Will it happen a lot?
No.
No. Yes.
I mean, isn't this a bit like, coin flip is too obvious of an example, but like, in gambling, you can be outside of what's normal a certain amount of times, but after a certain point, you've played enough games to where you're gonna converge towards what is considered average
Mhm.
for your expected gain or loss in that game.
So real quick side note, I don't know how many people like poker, ever watch it, ever play it. The really good poker players, they don't care if they lose tournaments. They're playing the long game. Everything you do is a long game. So if you play so that your expected value is higher, every single table, eventually you're gonna make some money. So if they lose, sure, it bums them out that they lost, but they know they're playing the long game. I'm not sure if that's really, I think that's really good.
Sort of. I'm thinking like one guy sitting at a table, and actually this happens in craps sometimes. I'm getting a bit too detailed, but you play like 5 rounds of dice, and you lose all of them, and you're like, damn, that sucks. But you're towards the one end of the distribution. You double down or put more money and stay there for a few more hours if you can afford to do so.
Sure.
You're more likely to come towards the middle of what the
Totally.
distribution would be.
Yeah, and this is the old adage, you gotta have money to make money. So the people that have enough money, they can gamble long enough until they hit that return on certain games. Yeah. Craps is a really good example where if you can play it long enough, you can get a place where you can get some good returns.
I think video
Alright.
poker has like the lowest house.
Yeah, yeah. Okay. Sorry, that was a big side note. I'm sorry. Is everybody roughly grasping what's happening? Now I understand it's hard for you to fully appreciate that it becomes like really good and normal. But again, it's just what we observed. And again, it's whatever the standard deviation is here, how does the one for this one relate? What does standard deviation mean? Again, what does standard deviation tell us?
Number of steps away from the mean.
No. Standard deviation is the step, so it can't tell me the number of
size
steps.
of the step.
Yeah, so be precise. What does the standard deviation tell me? The average distance from the mean to all of the data points. You with me? Is there any data points close to the mean in this first one?
No.
No. Whatever the standard deviation is this guy's standard deviation bigger or smaller?
Like, smaller because it's
Smaller, yeah. Isn't there more shit close to the mean, right? So isn't his standard deviation gonna be smaller? It's closer to its mean. What about this guy?
Even closer.
Even smaller. Now, real quick, let me see if you guys are all with me on this. Let's see. Every semester is a little different. This always reminds me of the, I don't want to go there. Somebody, if we're going 80 miles an hour, how far will we go in an hour? And she didn't understand that it would be 80 miles. Anyway, okay.
Oh, those viral.
Yeah. Sorry. If I took every individual person's age and I averaged them up, I'd get a number, correct?
Yes.
What if I took every pair of people, took their averages, and then averaged them up? Would it be different from or the same as everybody's average?
Different.
Be the same.
Oh wait, no, ages are
Could
normal.
you be-
No, ages aren't normal.
Could you be doing everybody's, this, as long as you're doing everybody's.
So let me ask you this,
actual ages
do you think it would go up or down if you think it would be different?
Oh.
In which case I would ask you, you're all the same people. By doing this, did I make you all age?
No.
Stop, Mr. Waller,
But
stop!
it would go down, wouldn't it?
Get liver spots.
You just illustrated how if you average things or take bigger sample sizes.
But
you're
it-
going from-
Oh, no, I see, I
It's
see, no, no, no.
it's the same
Yeah.
No, no,
sample
no.
size. so it's just
That's what I
the same.
Remember, I need you to understand. What does that dot represent?
10 people.
One group of 10, yes? Okay. My question isn't the standard deviation, my question is the average. Now, I've sort of shown you the average stays the same throughout, which is the reality. Now, real quick, what about the number 1, 2, 3? What's the average? It's 2, so the average is 2. Go with me now. You ready? 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. Does everybody agree that's all the groups of 2 I can make?
Yeah.
Okay. What's the average of 1 and 1?
1.
1. Holy shit. Average of 1 and 2.
1.5.
Average of 1 and 3. 2. Yeah. Alright, so this now are all the averages of every pair that I can make, correct? Alright, real quick. You ready? If I add these up, you ready? I'll get 4.5 there, is that cool? I'll get, what do you get there, Jeff? I don't know, I'm tired. 6, I think? And if I add those up, I'll get 7.5, is that right?
Yeah.
Okay, everybody's still semi with me. So when I did them individually, I got an average of 2, right? When I did them in groups, let's see what I get. 4.5 plus 7.5 is 12, plus 6 is 18. And how many groups did I get? 9. What's 18 divided by 9?
Still 2.
Frickin' 2, of course it is. They're the same stupid numbers. I don't care if how I organize them. When I average them, I should get the same number. I shouldn't get something high. You don't all suddenly age. You don't all suddenly get younger. I'm sorry. Math doesn't have that kind of magic. Right? But of course I get the same number. I don't care if I pick 2 at a time and then average those averages. You're all the same people. So my point is, the standard deviation, does everybody agree, even if you don't fully, does it make sense that it's going to get smaller? Whatever the standard deviation is, I'm going to call it this. You ready? I'm going to call it the standard deviation of the sample means. That symbol, does everybody agree that's the standard deviation? I'm going to put a little subscript of the sample means, right? Because remember, what did each of these dots represent? Groups of 10. So this is the average of a group of 10. Isn't that a sample mean?
Yes.
Okay, so this is less than that. So this is also going to be sigma x bar, but it's going to be for a group of 40, and this is less than sigma, and it's less than this guy. It keeps getting smaller. But my mean, I don't give a shit if I put them in groups of 10, groups of 40. They're all the same people, right? So the average is going to stay the same. And I'm assuming this process doesn't take like a year, so they all naturally age. No. Right, so these are all the same. The mean stays the same. Everything just sort of comes in towards the middle. If I went out right now and I randomly picked one person and they were 6'2", would you like freak out?
No, it's possible.
If I went out right now and I took a random sampling of 20 people and their average height was 6'2", would that be weirder?
You're in Norway.
That would be much weirder because a group of 20, I would expect them to be closer to the average height. Yes? guys understand that? Does that make more sense? That's really all I'm doing up here. Okay. I like how some of you guys are like, yes, just get to the point. Okay. So here is the part that we can't really prove. But we at least know the standard deviation does change. It should get smaller as my sample size goes up, yes? Is everybody with me on that? Please tell me you're with me. Standard deviation definitely gets smaller every time I bump up how big each sample is. It's going to get closer to the actual average. If my sample size was the size of the amount of people in Florida,
It's not a sample, it's a population.
yeah, then wouldn't it look like this? Are you guys, do you see how in the extreme it comes, bam, it comes right, so every time I take a bigger group, it gets closer, it just keeps getting closer to the mean, just keeps getting closer to the mean. Because it gets harder and harder for a group of 40, 80, 1,000 to be at some extreme. Maybe? If I went out and took 1,000 people and their average height was 6'2", now I'm like, where the shit am I? Right? I tried to pick a height that wasn't too weird, but once you start talking about an average of a large group, you're like, okay, that's weird. I wouldn't expect an average of somebody to be 6'2". Randomly selected people. Okay. Yeah.
Norway.
Yeah. We might be in a different country because, Norwegians are definitely generally more healthy than Americans, so they have their height, average height is definitely bigger. Freaking Norwegians. Okay. So here's the whole idea. So when I take a sample, from any distribution, I'm going to take a sample from any distribution and I plot the means. Take all samples of size n, there we go, from any distribution and I plot the sample means. One. As n increases, the distribution becomes more normal. N greater than 30, it's normal, what I call normal enough. Normal enough for what, Jeff? To go out in public. No, shut up. Normal enough. Do we have a piece of paper that's got like all the answers and something?
The answer.
Sorry. When am I allowed to use that piece of paper?
Standard one.
If I have a normal distribution, I can always make z-scores. So if I have a normal distribution, I'm allowed to use this chart that's got all the freaking answers to any probability question. You with me? So that's what I mean by normal enough. If my sample size is more than 30, I can use the z-score chart. If it's not, I have to use some weird shit that we can't even do in stats 1. It would be stats 2. You guys semi with me? A little bit? You're a little bit with me? Okay. Sorry. Like I'll be with you, but over there. Okay. By the way, Eddie and Eddie, that's awesome. Sorry. Double D. Okay. Haven't seen that forever. Alright, so that's part of what we talked about earlier. Also, the means stay the same. So the mean of the sample means is the same as the original mean. I don't care how big the sample is you take. Okay. And then finally, the standard deviation of the sample means. We know it's going to get smaller as my n increases. So as I pick more and more, as if my sample size gets bigger, the less likely it is for the resultant average to be far away from the real average. I have got to get closer and closer. So sure enough, it kind of makes sense. It doesn't make sense why it's exactly this. But as n increases, what does this do? As n gets bigger, what does this do?
The standard deviation gets smaller.
It's smaller. There you go. So as n increases, this decreases. So the new standard deviation is what I call this sometimes, is the old standard deviation divided by the square root of n. Okay. So let me immediately follow this up with a concrete problem, and then we're gonna leave really early. Is everybody okay with that? Does anyone feel cheated? I've had this happen before. I had a student say, I paid for this shit. I'm like, you sit here and study. I'm leaving. Sorry. You know I'm all about the study, but I'm also
It's
all
probably a
about...
couponer. He's like, I'm gonna get.
Alright, so here's a problem. Here's a problem exactly like you'll see. So after the break, we're gonna sort of review this. I just want to lay the groundwork so it's like in your subconscious, you know, giving you weird dreams. Alternate universe, Florida, right? But also when we come back from the break, I'm gonna sort of review this. I'm gonna have a beautiful little handout with the most colors on it of any of my handouts, which is like 2. It's gonna be a concrete example of this alternate universe thing I keep talking about. You guys kind of with me? So it's gonna be a way to review this, and then I'll have some more concrete examples. Everybody got what they want from this? More than you wanted? I understand. So, let's say that I know the average, oh God, now I gotta make something up. The average, I'm sorry, my brain is so spent. The average amount of money, I don't care the average,
The average amount of money that the average people have in their retirement account is less than $10,000.
okay, so let's say the average credit card debt is $3,500. Okay, right? You guys with me? I take a sample. Oh, and also the standard deviation is 800. You guys all with me? So it's got to give me those two things like always. I take a sample of 52 people. What's the probability that their sample mean credit card debt will be more than $3,600? Now I want to point out a couple things. I know z-scores are generally, the z-score chart is kind of new to us. Can you guys start to see, I'm going to point something out and then I want to see if anybody noticed the problem. Can't I make a z-score out of this?
Yeah.
Wouldn't I be able to look that up and blah, blah, blah?
Mhm.
2 problems. When am I allowed to use a z-score chart?
Normal distribution.
Did I say it was normal?
No, but we
No,
look at the
but-
number and
yeah.
compare it to 30.
So, 1, n equals 52, which is bigger than 30. So I know it's approximately, or it's normal enough, let's say that. We know what normal enough means. Normal enough to use the sheet, right? Now, here's the thing. I really want this to make a lot of sense. The standard deviation they gave me is for individuals. It's how far from this mean to each individual's credit, right? Or what did I say? Debt, thank you. You guys still with me? I'm talking about a group of frickin' 52 people. But that don't mean shit to me. This is for individuals. I need the spread for groups of 52 people. So the right way to look at what we're about to do is that the standard deviation they give me is for individuals. I am talking about a sample of 52 people. That number doesn't do shit for me. Sorry. You just don't. I need the number that's the spread for groups of 52. So when I do this, I am adjusting that to become the spread for a group of 52. That's what I need, yes.
So in the earlier, before you erased it, you said that the formula, I was confused by it. Standard deviation x bar is equal to standard deviation that you originally get divided by the square root of that same standard deviation. That's
No, of n.
divided by n.
Yeah.
Correct.
Right, divided by square root of n. By the way, does everybody see this is not sigma over x or something silly? This is sigma sub x bar. This is a subscript.
Mhm.
Very quickly, do you guys remember the formula for, this is coming out of nowhere, I know. Formula for slope from algebra, remember, is y2
Y equals mx plus b.
minus y1 over,
Oh, that.
Anybody remember this?
This point slope form.
what did the little 2 mean?
It's the
Second point.
second point of y.
You guys with me? Subscripts just mean a specific this. So what's sigma x bar? It means the sigma for sample means. That's all that is. It's one symbol. Just like y2 is one symbol. You would put the second point to y there. Yes? Subscripts are very often misunderstood because you don't see them very often. So what was the old standardization? What was the one for individuals? 800. And what's the sample size?
Square root of 52.
Sample size 52. So I'll do square root of 52.
110.940.
110.940.
940. Yeah.
Okay, let me stop for a minute. So we went through a whole thing with alternate universe Florida, we did blah, 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 blah. The only new step for what we do in chapter 6 is what we just did. Now I do all the same shit. How do I draw the picture for this? It's normal, right? What goes in the middle? Which is? 3,500. What else do I put down here?
3,600.
3,600. Which one am I gonna shade?
To the left. Or right, my bad.
Up, yep. You guys with me? All the same stuff, right? This is kind of nice. Chapter 7 is exactly the same as chapter 6, except for one step. When I take a here, you ready? Okay. Whenever I take a sample and I ask about the sample mean, when those two things happen, I must change the standard deviation. I can't use the one for individuals. I must figure out the one for groups of size, whatever. Yes.
Why did we say greater than 36?
What?
36?
Greater than 30.
Oh, this is the question.
Oh, that is you. Oh, yeah, yeah.
Sorry.
cool.
Yeah, this is the question. So,
Yeah.
is that okay?
Yeah, totally.
Yes.
We haven't finished, right? 'Cause we've
No. We definitely have finished. So now I can make a z-score, correct? How do we set this up?
3600.
Good. My data point minus the mean divided by the appropriate spread.
Which is the new thing we just found.
Yep. Which is 110.9. The idea is trippy. The work, simple.
Z is 0.90.
0.90. Neo. I don't say anything. Take a minute. Look that up. We got a z-score now, right? Look that up. It's all the same steps, correct? It's all the same steps. All the same steps, just one extra step. I can't use the standard deviation they gave me because that's for individuals, and I want groups of size 52. I have to change that. When you look at 0.90, what do you get?
0.81.
What?
0.8159.
5.9?
Yeah.
Okay. So then, of course, the answer would be
1841.
1841. Sounds like a history quiz.
Well, no, we just looked at the opposite of the z-score. So negative 1.0.
18.41%.
Would you take normal enough as an answer? On
Yep.
the test?
What do you mean? Yeah, so you always have to tell me why you're allowed to use the z-score chart. So either I tell you it's normal, or the sample size saves your ass, yes? So this sample size was 28, we could not handle that in stats 1. That would be a stats 2 problem, and the problem with that is, we don't teach stats 2 here. Damn it.
Oh, so you won't ask us that?
Oh, I was gonna say, if,
Nope.
if we get a question on a test that says, your sample size is 27, can you use this?
Oh,
You would stop at
I
no.
could ask a question where I would say, would you be able to do this?
He's like, no.
But I wouldn't just give it to you and go, if you don't notice, you're gonna do a lot of work you shouldn't, I'm not gonna, there are
Someone's
problems,
gonna try.
there are problems I could put on a test where if you don't notice you're not able to do it, you'll do all the work and you're wasting time. I'm never gonna do that, that would be so evil. And if I do, you can kick me in the leg.
I was waiting on this quiz, like, is this distribution valid? Is it more than 1? Is it less than 1?
So I would never give you a distribution that wasn't valid and not tell you. Like the question would be, is this valid? It wouldn't be figure out all this stuff, right? Because then you're like doing the busy work. Anyway, okay. Is everybody semi-okay with that? Right now, there's people out there going, I'm just gonna say yes. Then he's gonna say the magic words, that's enough. That's enough. So don't get used to this. That's a lot, that's early. Don't get used to it. Hope you have a good break. And if you need to, I'll see you before that, but otherwise I'll see you after that. If you're working on stats at all, you can send me an email and I'll get back to you whenever I want to.